All right, so we started yesterday with the trig functions of any angle. Before I get into more of what we talked about, like more examples and stuff, this was the biggest one, right? So, and this, Miss Ferrier was just like, you forgot the theta. This would be sine of theta or sine of s, okay, is what they use for the angle in radians, is y, sine of cosine is x, tangent is y over x, and then the inverse functions we just flipped, or the reciprocal functions we just flipped them. So if I had just picked like a random angle on my unit circle, let's say I say 7 pi over 6, and I ask for the sine of 7 pi over 6, you would give me the y coordinate there, which would be negative a half. The cosine of 7 pi over 6, you'd give me the x coordinate there, negative root 3 over 2. Tangent of 7 pi over 6, and we added on, right, we did over 3, over 4, and over 6. The over 3 is root 3, the over 4 is 1, and the over 6 is root 3 over 3 for tangent. So we talked about that yesterday. So the tangent there would be a positive 1 because it's a negative over a negative. And then the reciprocal functions we didn't get into yesterday. So if I flip negative 1/2, I get negative 2, 7 pi over 6. If I flip negative root 3 over 2, I get negative 2 over root 3, which has to get rationalized. Negative 2 root 3 over 3. If I flip 1, it stays as 1. So you want to be able to find any of those. Quiz-wise, it's not going to ask you for all 6. It's just going to ask you for one specific one.
Why is it 1 for tangent and cotangent?
Oh, not 1. Sorry, I was thinking of pi over 4. Just kidding. Not 1. This is an over 6, so this would be root 3 over 3. And then when flipped, it'd be 3 over root 3, which gets rationalized, and that's root 3. Sorry, thank you. So the rationalization of the reciprocal of root 3 over 3 is root 3. Save yourself some time and kind of learn that, okay? It will ask for like secant of an angle or tangent of an angle, but it also won't be, remember we talked about yesterday, it won't be actual unit circle based. It would be bigger or smaller than unit circle. It's going to be a coterminal. Like a 13 pi over 6, a 17 pi over 6, a 25 pi over 6, something like that, where you've got to figure out the coterminal. Okay, then we worked through these examples and we left off here. So it says use a calculator to find the trig function and round to 4 decimal places. Now hint, we should now be in radians, okay? So this is going to say cosine of 1.85, and there's no degree symbol there. Notice there's not a single degree symbol on this entire slide, and that's intentional. Normally we would say the tangent of 30 degrees or the cosine of 65 degrees, right? And it would be in degrees. And now it's not. They don't have pi, but they don't have a degree symbol either. So these are in radians. So on the calculator, depending on which calculator you have, if you have the graphing one, you want to hit mode. And you'll see that the 1, 2, 3, 4th thing down says radians or degrees. Now you want to be in radians. If you're using like a scientific one like this, like that pink one, then it's at the top, it says DRG. You hit DRG and you arrow over to RAD. So we go from DEG to rad, which is radians. And then we just type it in. Cosine of 1.85 is negative 0.27. It says to round to 4 decimal places. To 27559. This 9 bumps up the 5, so negative 0.2756. 10 is cosine of 0.5149. So again, keeping it in radians, cosine 0.5149. And I get 0.87034. The 4 drops off, so my answer is just 0.8703. Cotangent of 1.3209, I'm doing 1 over tangent, 1.3209. And I get, and I get 0.25523. The 3 drops off, so I get 0.2552. All right, finish out the slide. So find the secant, the sine, the cosine, and the tangent.
This question is when I open 1 over tangents would have like 1.3209 each other, but with the same factor.
Which calculator are you using, Ethan?
I am using a graphic calculator.
Okay, you did 1 divided by tan 1.3209. Can you show me your screen? Like just put your put your calculator right in front of the camera.
Okay.
Oh, I totally can't see that. Hang on.
Wait, I think there's an extra parentheses.
I was gonna say I think that's what it is, right? Try that.
Alright.
And then let me know.
Okay, now I got it.
Okay, good. Okay, so we should have gotten the secant number 12, negative 1.0243, number 13.7314, number 14.5397, and 15.1944. Everybody good on those? Yes? We're good? Okay. On the homework, it throws back in the degrees. So if it had said cosine of 280 degrees, okay, now we got to switch back and forth. So make sure your calculator make sure you're comfortable doing that, because it's going to happen. Like, not on your quiz, because you won't use calculators on your quiz, but by test time, you've got to be comfortable switching them back and forth, because you're going to have to. So now I switch back to degrees, and I do cosine of 280. And I get 0.17364, so 0.1736. Okay, just pay attention and make sure that you remember to look for that. If it doesn't have a degree symbol, then it's in radians. And if it does have a degree symbol, obviously, then it's in degrees. So what if it had said cosine of pi over 7? What mode is my calculator going to be in? Radians. So try that, and you'll use the pi symbol. Don't use 3.14. So you'll use cosine of pi divided by 7, which is 0.999, well, I picked a bad one, 96, so this bumps everything, this becomes 1.0.
So for the quiz, it's not everything that I learned up to
Oh, I was in degrees, hang on, sorry, I told you to switch it and then I didn't. Go ahead, Sophia.
what we learned up to yesterday is supposed to be in the quiz, this stuff won't be.
This specific slide won't be, but we're going to move forward, and there's some stuff after this that will. Yeah. Sorry, this should have been 0.90096. The 6 bumps up the 9. The 9 bumps up the 0. 0.9010 should have been in, that's what it should be in radians. Okay? So just make sure that you pay attention, because that's like an all or nothing. There's no like work I could give you partial credit on. It's all or nothing. You're in the right mode or you're not. Okay? And you will have to flip-flop back and forth between them. Okay, so we talked last chapter about reference angles dealing with degrees, right? We said if something was in the first quadrant, then its reference angle was whatever it is. 30 degrees, reference angle is 30 degrees. If something was in the second quadrant, we did 180 minus that angle. So we would do like if it was 150 degrees, right? We would do 180 minus 150 and I'd get 30 degrees. If it was in the third quadrant, we did 180 plus whatever they give you, and that's the reference angle. No. Sorry. We do the angle minus 180. There we go. And that's the reference angle. Otherwise, it's a little too big. And then in the fourth quadrant, we would do 360 minus the angle. And that's our reference angle. And we said the reference angles always fell between 0 and 90, including 90. So it had to be less than or equal to 90 degrees. So if I told you it was 120, you'd know that's in the second quadrant. You'd do 180 minus 120, and your angle there would be 60 degrees. Now we're comparing it to radians, okay? So if you have a calculator, then you're actually going to use the pi symbol for these. This would be 2 pi. If you didn't, if you only had like a 4 function or something like that, then you can simplify it and say it could be 3.14. So my angle, let's just say that I'm looking for the reference angle of 2.5 radians. Where does 2.5 radians live? In the second quadrant. So I'm going to do pi because I have a calculator. I'm going to do pi minus 2.5. And I get my reference angle is 0.6416. Now this is important because we're about to combine this with our inverse functions. So you remember in the last chapter, if I gave you an inverse function, if I said sine of theta is a half, you had to give me the two angles in which sine would be a half. If I said tangent is negative root 3, you had to give me two angles, because it was the whole circle, on which of those angles would be root 3, right? So now we're about to do it with radians. So you have to know, all students take calculus, is going to tell you which of my quadrants I need to use. You're going to find your reference angle, and then you're going to find your angles based on which ones you should use.
How did you know it was in the second quadrant? Yeah.
Because it's, remember the second, so this is like 3.14, right? So the halfway point there, 3.14 divided by 2, this would be 1.57 radians. So if it's in between 1.57 and 3.14, it's in that second quadrant. If you want to actually write that on your, because you get that reference sheet, then the third one would be halfway between 6.28 and 3.14, right? I mean, yeah. So it's 2 pi. It'd be 2 pi. It's pi and a half, right? So that's what it is. 1.5 pi. And that's 4.7. That's without the pi's, right? Because this is pi over 2. This is pi. This is 3 pi over 2. This would be 0, and then 2 pi, which was also 6.28. So without the pi's, you get those whole numbers. That's going to tell you which quadrant it lays in. So 1.5-ish at the top, 4.7 on the bottom, and that kind of determines your range.
So,
You sure?
So after you find like the 0.6416, I didn't understand what you're saying.
So if this was, that would be my reference angle, right? So we haven't gotten to it yet, but let's just say it said the cosine of, uses s instead of theta in this section because it's radians, but like let's say cosine of this angle, we don't know the angle, equals 0.4, right? I'm going to inverse cosine that, so cosine -1, and I'm going to get the angle. But then I'm going to remember that cosine is not just positive in the first quadrant, it's also positive in the fourth quadrant. So I keep the angle that's on the answer for my calculator for the first quadrant one, but then the second one, I have to take that angle and subtract it from 2 pi. There's always going to be those two options.
So it's like what we did before.
But we did it with angles in degrees, right? Now we're doing it in angles in radians. So we used 180 and 270 and 360, and now we have to use pi, 1.5 pi, and 2 pi. Okay, so it's now, notice the difference. On the last slide, it said cosine of something, and we found it. Now it's saying cosine of what equals this. So this is when we use our negative ones. So we have to use cosine negative 1. We have to use sine negative 1. We use tangent negative 1, okay? Or we use cosine of negative 1 of 1 over the value, sine negative 1, 1 over the value, tangent negative 1.
How did you know that you have to use?
Because this time what we're looking for is an angle. On the last slide, like look back. Let's say it says cosine of 2. I'm using my regular button. If it says cosine of s equals 0.2, now I'm using my inverse buttons. What I'm looking for here is the trig function, and what I'm looking for here is the angle. Just kidding. That's really helpful. Why did you stop?